Hi there, my name is Cara Marie and I'm going to help you through this problem. Problem is really easy if you're able to use a grapher, which I have on the board. All right, so we'll go over how to use the graph to determine it, and then if you can't use a calculator, we'll go over how to determine the answer without a calculator. All right, so if I look at the graph, we remember that the range is the allowed y values. Right, and it looks like our y values, all of them above -1, which is the bottom of that parabola, is allowed. So our range should be from -1 all the way up to infinity because this parabola is going to keep going on and on forever. All right, and I'm going to note here that this vertex is 5 minus 1. All right, now that's the answer if you are able to use a calculator. If you're not able to use a calculator, I'm going to teach you how to complete the square to get it into vertex form. So the way that I like to do this is I take my equation and I create an imaginary equal sign. I move the number alone over to the other side by subtracting 24 on both sides so that I have x squared plus 10x, and then on my other side is equal to minus 24. To complete the square, what you do is you take this 10, you divide by 2, which gives you 5, and you square it, all right, which is 25. All right, and then I add this to both sides of my equation. All right, because what I do to one side, I must always do to the other. So now with that, I'm left with x squared plus 10x plus 25 is equal to 1. All right, and then we're going to note that this is x plus 5 squared, all right, is equal to 1. All right, and then now I'm going to bring my 1 back over so that I get, and I'll put it in another color, the vertex form of this parabola, which is x plus 5 squared minus 1. All right, and then this gives me the coordinates of my vertex. All right, my vertex would be at, oh, I'm sorry, this should be a -5. All right, my vertex should be at -5, -1. All right, and then because this is positive, we know that we're going to go from -1 up to infinity for the range.